Hey, hello everyone. I am Shivam Chaturvedi, and as I have promised to you that I will finish this chapter number 3 in my next segment, so I am keeping my promise in this video. And let's start the last topic of chapter number 3, that is electronegativity. There is a slight difference between electron affinity and electronegativity, so let's revise electron affinity first, which we have discussed earlier in our previous video. That electron affinity is that the atom, this is an atom and this is its nucleus, and when an electron comes towards the outermost shell of this atom, this outermost shell accepts that electron and releases some energy, and that energy is known as electron affinity. Listen it carefully what I am saying, that this electron is being accepted. Okay, the accepted is the key word here. And now the electronegativity is the tendency of an atom, the tendency of an atom to attract a shared pair of electrons in a covalent bond. Definitely, if I am saying about the shared pair of electrons, then I am talking about uh, the covalent bond. Now let's take an example about what I want to convey you about the electronegativity. Okay, so let's take an example of hydrogen fluoride. Hydrogen fluoride. This is hydrogen fluoride, and we know that hydrogen has one electron and fluorine has 7 electrons. If we do their electronic configuration, so 1s1 is hydrogens and fluorines is 1s2, 2s2 and 2p5. So first shell of hydrogen has, so let's make these structure. This is hydrogen's nucleus and this is its one electron, and this is fluorine's nucleus. This is fluorine. This is first cell having 2 electrons and this is its second cell having 5 electrons. So if I make these 5 electrons as 1, 2, 3, 4, 5. So to complete the duplet of hydrogen, it needs only 1 electron, and to complete the octet of fluorine atom, it needs 1 electron. Okay, so they will share electrons with each other and form a covalent bond like this. Okay, so can I represent it via this hydrogen fluoride? 1, 2, 3, 4 and 5. So this is the covalent bond between hydrogen and fluoride. Now according to the electronegativity, this fluorine is the most electronegative atom. We will discuss it later why is it the most electronegative atom in the periodic table. Okay, so this is the covalent bond, and this electronegative element will attract, according to the definition of electronegativity, will attract, because it has the tendency to attract a shared pair of n electrons. So this will attract this shared pair of electrons. So now your question should be that will this covalent bond break? So my answer is no. This covalent bond will not break. It's just a slight tilt of shared pair of electrons. Okay, so this is the definition and explanation of the definition of electronegativity. Now let's take an example of chlorine and fluorine, and by that examples I want to convey you that what is the difference between electron affinity and electronegativity. And to make it more interesting, I will I will tell you a story. Okay, now this is chlorine and this is fluorine. This is the most what electron affinity, it has the most electron affinity, and this is most electronegativity. Okay, let's make it interesting. So this chlorine as I have told in my last video, this is more this has more electro affinity than electro than fluorine. Okay, so why this has more electron affinity than fluorine? And I told you earlier that this has more atomic size to accept an electron. So this, can I say this, a boy, a husband who has a government job, okay, and this is a nibba. This is a nibba. Um, Nowadays nibba are very prepared. This is a nibba who don't have any kind of money. इसके पास क्या है? Money नहीं है. Money, who has not money, but has KTM, has DSLR, and all that, and all these stuffs. So this is very attractive, but its size is very small. This, so it cannot accept any electron, incoming electron. Okay, and this size is, and chlorine's size is bigger than, bigger as compared to this. So this can provide, chlorine can provide the upcoming electron a shelter, which is needed, which is needed to be accepted. Okay, यदि किसी इलेक्ट्रॉन कोई आ रहा है और उसको रहना है, मान लीजिए एक्सेप्ट होना है, तो एक्सेप्ट होने के लिए बेसिक नेसेसिटी क्या है? बेसिक नेसेसिटी है कि आप उसको शेल्टर प्रोवाइड करें. तो शेल्टर प्रोवाइड करेगा कौन? हमारा क्लोरीन, जो कि है इलेक्ट्रॉन एफिनिटी. बट दिस इज नॉट इन द केस ऑफ फ्लोरीन, बिकॉज फ्लोरीन्स work, fluorine's main function is to attract the shared pair of electron. Okay, so this is the difference between electron affinity and electron negativity. This will attract electrons and this will accept electrons. Again I am saying that, let's revise it. Chlorine is most electron affinity and fluorine has most electronegativity. Okay, what is the difference between them? Electron affinity is the acception of electron, accepting of electron, and electronegativity is the attracting of shared pair of electrons. Okay, for being accepted one needs a shelter, and that shelter provided by, that shelter is provided by chlorine. Why? Because chlorine has more atomic size to accept an electron. Because if it has lesser size, so because due to the electronic repulsion it cannot sustain in chlorine's outermost shell like फ्लोरीन. यदि फ्लोरीन का जो साइज है छोटा, उसके पास आते इलेक्ट्रॉन्स, और चूंकि इलेक्ट्रॉन रिपल्शन के कारण वो रहने नहीं देते, साइज छोटा, इलेक्ट्रॉन आ रहे हैं, पहले से भी कुछ इलेक्ट्रॉन्स हैं, एक नया इलेक्ट्रॉन आया, तो चूंकि इलेक्ट्रॉन्स और इलेक्ट्रॉन्स आपस में एक दूसरे को रिपल कर रहे हैं, इसलिए वो रहने नहीं देते. तो हमारा काम क्या है कि वो सिर्फ अट्रैक्ट कर रहा है, रहने नहीं दे रहा है. रहने देता तो इट शुड बी, इट वुड बी अ accepting of electron, and that will come under the category of electron affinity. Okay, and the second most difference is that this releases some energy, so it has an absolute value and absolute value, and this has a relative value. What does it mean by a relative value? That it does not have any absolute value. And what does it mean by relative value? Relative value is like the fluorine is most electronegative, then oxygen, then nitrogen, then chlorine, like this. So if I say that fluorine is 4x, fluorine is 4x, fluorine attracts a some pair of shared pair of electrons by 4x speed in a ratio wise. So then oxygen will attract these shared pair of electron by the speed or by the force of 2.8x. Okay, so this is the relative concept and not just a absolute concept. Okay, यदि कोई electrons, shared pair of electrons हैं, उनको फ्लोरीन खींच रहा है 40 की स्पीड से, 40 न्यूटन के फोर्स से, ठीक है, 40 न्यूटन के फोर्स से खींच रहा है, तो यदि उसी इलेक्ट्रॉन को ऑक्सीजन उस रेशियो में जब हम देखेंगे तो वो 3.8, आई एम सॉरी, इट्स 3.8 की रेशियो से खींचेगा, ठीक है, 38 की स्पीड से खींचेगा, 38 न्यूटन से खींचेगा. तो ये क्या है? we are talking in the terms of ratios. Okay, absolute value, relative value. Okay, this is the difference, I think. And this has unit, because it releases some energy, so it has unit electron volt per atom, and it is unitless. Okay, this is the third. So what are the three differences? First is that it accepts an electron and it attracts a shared pair of electron. It has absolute value and it does not have any absolute value because it deals in relative concept, and it has some sort of units like electron volt per atom because it releases energy, and it does not possess any kind of unit. Okay, this is the difference. Let's move further to the second subtopic of this detailed topic, like that is factors affecting electronegativity. This is same as the electron affinity. First is atomic size. Second is nuclear charge. Third is charge of cation, and fourth one is charge of anion. Okay, so let's revise the electron affinity because at the starting these two are same. When atomic size increases, moving down to the group, when atomic size increases, this is first atomic size, this is its nucleus, and this is second atomic size, this is its nucleus. Electron is revolving around this and it has to attract electrons. Okay, this is the shared pair of electron and this is the shared pair of electrons. So this nucleus and this nucleus have to attract these shared pair of electrons. So which nucleus will attract it more as compared to other? So this will attract. Why? Because the distance between this nucleus, the positive charge, and this electron, the negative charge, is slightly less as compared to this. And if we get towards, if we go for the F equals to 1 by r square, that is the electrostatic force of attraction, the formula of electrostatic force of attraction, we will find the force of attraction is inversely proportional to the direction between and to the distance between the two charges. Okay, so first charge is positive charge and the second one is negative charge. Definitely they will attract each other. Okay, so this distance is quite less than this distance. So as size increases, so force of attraction will decrease, and as the force of attraction will decrease, electronegativity will also decrease. Okay, यदि ये इलेक्ट्रॉन्स को खींचने में ये दूरी कम होती जाएगी, ये वाली दूरी कम होती जाएगी इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन की फॉर्मूले के तहत, तो ये दूरी जितनी कम होगी फोर्स ऑफ अट्रैक्शन उतना ही बढ़ता चला जाएगा. जैसे ये बढ़ता चला जाएगा और ये दूर हो गया तो ये फोर्स ऑफ अट्रैक्शन कम हो जाएगा. तो ये हम पास में लेके आए तो एटॉमिक साइज को छोटा करना पड़ा हमें. कैसे? शेल नंबर्स घटते जा रहे हैं, न्यूक्लियस वहीं पर है, शेल नंबर घटते जा रहे हैं, इलेक्ट्रॉन और पास आता जा रहा है. तो एटॉमिक साइज जैसे बढ़ेगा तो इलेक्ट्रोनेगेटिविटी कम हो जाएगी. तो कैन आई से दैट इलेक्ट्रोनेगेटिविटी is inversely proportional to atomic size. Okay, and the second factor is nuclear charge. Nuclear charge, as we all know, that number of protons an atom has. Okay, so number of protons is the nuclear charge, and when number of proton increases, the polars are increasing. Remember it, the polars are increasing. So when polars are increasing, they will pull it more efficiently. Okay, so when they pull it more efficiently, electronegativity will also increase because खींचने वाले ज़्यादा हो गए, polars are increasing, so the pull is also increasing, and pull is actually the force of attraction. Okay, so if the force of attraction is increasing, the electronegativity will also increase. So can I say that electronegativity is directly proportional to the number of protons or the Z or the nuclear charge. Now the third one is charge of cation and charge of anion. So can I rub it? this is an atom, this is its nucleus. Nucleus has positive charges, some neutrons are also there, and this is the shared pair of electrons. Okay, when we increase the charge of cation like this, electron, 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 electron. Okay, so when we increase the charge of cation, so cation is what? Cation is when an atom becomes a cation when it loses an electron. Okay, so when we increase the charge of cation, definitely it is losing some electrons. Okay, so when it losing some electrons, electrons are removing from an atom, so the force of repulsion between electrons will decrease, and when the force of repulsion between electrons decreases, it is ready to accept another electron more efficiently. Okay, so when they are ready to attract more electrons efficiently, so the force of attraction will also increase, and when the force of attraction increases, their electron negativity will also increase. Okay, so the charge, if we increase the charge of cation, electronegativity will also increase. So electronegativity is directly proportional to the charge of cation. Okay, and in anion, what we do is the addition of electron. When an atom gains an electron, it becomes anion. So when an atom gains some electron, this electron, this electron, this electron, it becomes anion. And when we are increasing the charges on anion, so definitely we are adding some electrons in it. So when we are adding some electrons in it, the force of repulsion between electron also increases. When the force of repulsion between electrons increases, it is not ready. Now it is not ready to accept that electron. So now electronegativity, the pulling, the efficient pulling will also decrease. Okay, why it is decreasing? Because of the increase in force of repulsion between electrons. Now atom is not ready to accept more electrons, so it will not apply any kind of pull towards these shared pair of electron. So now the electronegativity decreases when the charge on anion increases. So can I say that electronegativity is inversely proportional to the charge on an ion? Okay, so these are the four factors. The fifth factor is about the hybridization, and I would like to stay till here. Why? Because the hybridization is the topic of chapter 4, and I would like to make you understand hybridization first, then I will relate it to the electronegativity. Okay, now moving forward towards the trends in periodic table. This is as simple as that. Trends is like the electron affinity. What is the trends in electron affinity is, first is period, on moving period from left to right, and second is bottoming in the group, from top to bottom. Now from left to right, nuclear charge is increasing, same phase as the electron affinity. As the nuclear charge is increasing, and because the nuclear charge is directly proportional to electronegativity, so electronegativity will also increase from moving left to right in periodic table. Okay, so this electronegativity increases. Okay, and when we come from top to bottom, number of shells are increasing. Number of shells, one shell, two shell, three shell, four shell, number of shells are increasing. And when the number of shells are increasing, definitely the atomic size also increases. And when the atomic size increases, and we discussed this in our first factor, that atomic size is inversely proportional to the electronegativity, and as moving down to the group, atomic size is increasing, definitely the electronegativity is decreasing. So from bottoming in the group, from moving top to bottom in the group, electronegativity decreases. And the third subtopic is the application of electronegativity, which I will discuss it later. Okay. So after discussing the explanation, trends, and the factors affecting electronegativity, let's move further and let's discuss the application of electronegativity in chemistry. Okay. So before moving on, I would like you to have a look at this table. Now, what is this table? This table is about the relative concept of electronegativity. That if the fluorine is most electronegative element, and if I take it as 4x, so I will extend the ratios according to the ratios of electronegativity according to the its relative concept to fluorine. Okay. So if fluorine is 4% electronegative, it's unitless. I'm sorry, it's unitless. So if fluorine is F, and its electronegativity efficiency is 4, so O is 3.5, nitrogen is 3, chlorine is 3, bromine is 2.8, iodine, sulfur and carbon has 2.5, and phosphorus and hydrogen has 2.1. So I'm saying it, please learn it before moving on to the application part. Okay. So first application is about the nomenclature of binary compound. Now what is the binary compound? Binary compound when two non-metals combine. Okay. So if I write this HF, HCl, what would you name these? We would name these hydrogen fluoride, hydrogen chloride. But if I write this, so how will you name it? It's chlorobromide or bromochloride. So this is the first application of electronegativity when we use it in the naming of binary compound. So among these binary, यानी कि जहाँ पर दो non metals हों, where two non metals are there, so IDE suffix will add after the more electronegative atom. So in these, which is more electronegative, chlorine or bromine? So according to this table, this chlorine is 3 and bromine is 2.8. So more electronegative is chlorine. So its name is bromochloride. This is the right and the correct name of this binary compound, and you can use this application in further questions. Okay. Let's move to the second application of electronegativity, that is calculation of ionic character in covalent bond. Okay. And the formula for that is 16 del x plus 3.5 del x square. Now what is this del x? Del x is the difference in electronegativity of binary compound. Okay. Now if any bond, be it covalent, be it electrovalent, there is not any bond in chemistry which is 100% ionic or which is 100% covalent. Every bond has both characters, covalent and electrovalent. So this is the second application, which is the calculation of percentage of ionic characters in covalent bond. हमको ionic characters का पता लगाना है किसमें? covalent bond में. तो how will we find it? कैसे पता लगाएंगे? जैसे हमको दे दिया गया, let's take an example. Calculate the ionic characters in hydrogen fluoride first, hydrogen chloride. We all know that these are the covalent bonds, but for the calculation of electrovalent, for the calculation of ionic character, we will apply this formula. Okay. So the del x is the difference in electronegativity. More electronegative is fluorine here and chlorine here. What is the electronegativity here? Hydrogen's is 2.1 and fluorine is 3. So difference is 1.9. No, sorry, this is 4. So hydrogen's, yes, so the difference between is 1.9 and here the difference between chlorine is 3 and hydrogen is 2.1. So the difference between them is 0.9. Okay. So let's put that value here 16 in the case of HF. In the case of HF, 16 del X equals to, in the case of HF is 1.9 plus 3.5 into 1.9 square. Okay. Let's solve it further. 20.4 plus 3.5 into 3.61. Like this. Thirty-four point 005% is the ionic character in the hydrogen fluoride, and same as hydrogen fluoride you can also calculate for hydrogen chloride. Okay. And the third important application of electronegativity is the bond strength calculation. Like the question is like which has more bond strength. So bond strength is like which will attract more, like this electron, this is the atom and this is the electron, which has more attraction. It's like love, bro, it's like love. Which has more attraction, definitely it has more bond between each other. Okay. Like this is a atom, this is its nucleus, this is an electron's pair. So which has the more bond, the bond will increase bond strength. Bond is what? Love, and love is strength. Okay. So bond strength will increase when the attraction increases, and attraction will increase when the attraction is more in magnitude. When the attraction's magnitude is more, when the electronegativity is more, like these two atoms or this atom. Okay, first binary compound and second binary compound, hydrogen fluoride and hydrogen chloride. इसमें हमें ये निकालना है कि किसके पास ज़्यादा बॉन्ड स्ट्रेंथ है. उसके पास ज़्यादा बॉन्ड स्ट्रेंथ होगी जो इलेक्ट्रॉन्स को ज़्यादा बेहतर तरीके से अट्रैक्ट करेगा, और बेहतर तरीके से अट्रैक्ट कौन करेगा? Which has more electronegativity. So what will we have to calculate is the difference in electronegativity. So the more bond strength will be in the difference of electronegativity is more, where the difference of electronegativity is more, यानी कि electronegativity यानी कि attraction जहाँ पर ज़्यादा होगा वहीं पर bond ज़्यादा होगा. It's definite. Okay. So हमें देखना है यहाँ पर क्या कि हाइड्रोजन और फ्लोराइड, तो इसका क्या है 2.1 और इसका है 4, इसका है 2.1 और इसका है 3. So difference between electronegativity del En is here 1.9 and here is 0.9. So which has more difference in electronegativity? This hydrogen fluoride. So then definitely we can say that hydrogen fluoride has more electronegativity in binary compound. Difference has more difference in electronegativity than hydrogen chloride. And when this has more difference in electronegativity, we can conclude that the electrons are being attracted more efficiently. When electrons are being attracted more efficiently, so the bond between these two, hydrogen and fluoride, will definitely has more value than this hydrogen chloride. So we can conclude that difference in electronegativity is directly proportional to bond strength. You can also calculate this. Okay, bond strength. And the fourth one is the calculation of acidic character. So what is the acidic character? According to the Lewis acidic character calculation, acidic character according to Lewis, acid will be that which can lose H plus ion easily. So which will lose H plus ion easily? कौन H plus ion को आराम से लूज कर देगा? वो जिसकी इलेक्ट्रोनेगेटिविटी कम होगी, इलेक्ट्रोनेगेटिविटी डिफरेंस यानी कि जिसका that compound will lose H plus ion easily, which has less bond strength, and which has less bond strength, definitely its difference in electronegativity is less, because the difference in electronegativity is directly proportional to bond strength. Okay, so when H plus ion have to lose from that compound, its bond strength should be low, and when its bond strength should be low, the difference between electronegativity should also be low. Okay, जब ये कम होगा, हमारा बॉन्ड स्ट्रेंथ कम होगी, तो ये भी कम होगा, और ये कम क्यों होना चाहिए? क्योंकि हमें ये आराम से लूज कराना है। तो अब यदि हमसे कोई पूछे कि हाइड्रोजन फ्लोराइड और हाइड्रोजन क्लोराइड में मोर एसिडिक कौन है, तो वो है जिसका H प्लस आयन लूज हो जाए आराम से, यानी कि जिसकी बॉन्ड स्ट्रेंथ हो कम। और बॉन्ड स्ट्रेंथ किसकी कम होगी? जिसकी इलेक्ट्रोनेगेटिविटी होगी कम। तो इलेक्ट्रोनेगेटिविटी देखिए इसकी 2.1 and 4, 2.1 and 3. The difference between these two is 0.9 and these two is 1.9. So the difference between electronegativity in this compound HF is more than HCl. So HCl has less bond strength than HF, and when HCl has less bond strength than HF, definitely HCl will lose H plus ion easily, and when HCl will lose easily that H plus ion, it has more acidic character. So here we learned about the 4 application. First is the nomenclature. Okay, second one is calculation of ionic character, third one is bond strength calculation, bond strength comparison, and the fourth one is acidic character comparison. These are the 4 applications of electronegativity, and here I am concluding the chapter number 3 of your class 11th. Thank you so much. Jai Siya Ram.